All right, welcome back. In the previous video, we talked about using template functions to manipulate data in a list in a systematic manner. And we created functions for map, filter, and zip. Map maps a function onto a list and produces another list of the same size with the results of that function in each element. Filter can remove items from a list if they don't meet some criteria as passed in by the filter function. And zip combines two lists together, forming a third list of tuples containing each element of the two lists. In this video, we're going to shift gears from this concept to the concept of a template, which will allow us to replace list with a container type of our own specification. So we can use this with different types of containers. So how are we going to do that? Well, first of all, we need to comment this out. And we're going to comment this whole main function, and I will explain why. That is because these list functions we created will potentially create a conflict with the new templates when they try to build. And this really is not the correct way of doing this kind of thing. We're going to now do it the correct way. This was to teach the idea of a template. Now we're going to do it a different way, and what I'm going to do is create a new header file, and I'm going to call this collect functions. These are functions on collections, HPP, of any type. Or you can call them containers. Some people call them containers, some call them collections. Different languages have different ideas. Generally, we probably call them containers here more than collections. Collections is kind of a Java, C# kind of thing. But it doesn't matter what you call them. Lists, vectors, arrays, all this kind of stuff that hold, even tuples that hold stuff. There are different types of collections that do different things in different ways. Okay. So what do we need to do here? In the wrong file. Well, we need to put some includes in here. We need our functional group. This is for our being able to pass our lambdas in. And we need to include, well, no, that's all we need to include for now. All right. So what are we going to do? Templates. This gets just a little bit tricky. I'm going to type out this signature first, and then I'll explain it. We're going to have the T item type. Then we're going to have a template that takes a type name and a type name and a type name of T collect and a type name, TYPE name allocator. Okay. So why all that? So what we're telling it is we're creating a template. That's this template statement here. And this out to here is our template. From here to here is our template setup. The first type in that is going to be the type of the items being stored. And then we're going to tell it what kind of container that we want. And that is going to be a template type. So we're not going to pass in a type for this. We're going to pass in a template like list or vector or something like that. It's got to be a template type. And that template type has to take two type names. And the type names we expect it to take are tCollect and tAllocator. And we have to specify the allocator because the templates we're going to be working with have an allocator and they have a default allocator. So the template system is going to try to stick that allocator in. So we have to accept the allocator and we'll have to tell it when we use these exactly what we want to do. So just like we did before, we want to return our tCollect of type tItem, tItem, and allocator. Map tCollect tItem allocator collect standard function tItem and this is going to be our func. So this is our map function set up to take any, we've got tCollect, this needed to be allocator, I missed this here. We can close these up. And we need one down here. There we go. So we're going to return the type of collection we pass into this as a template that takes that item and some allocator appropriate to the item. We have to specify the allocator because we've gotten very abstract. It can't guess what the allocator is. I guess that's a better way of saying it. So we have to tell it the allocator. Our map function is going to take that collection of that type with that allocator as the collection, and it's going to take a function that takes the item and returns an item. It's the same as before, but now our result needs to be tCollect of type tItem allocator, and this is our result. And then we just go for auto item in collect. We go result dot pushback func item and return result. Now there's a couple of important things going on here. You might ask yourself, well, if it doesn't know until compile time what the collection is, how does it know that the item, that this result of this some kind of collection has a pushback function? Well, this is what we call duck typing. It's called duck typing because if it walks like a duck and it quacks like a duck, it must be a duck. And what that's saying is that if this type result does not have a pushback, you'll get a compiler error. It won't compile. If it does have a pushback, then it'll work just fine. So you can only use this with types that have this pushback function. That is, collection types that have a pushback function. That's the only actual requirement. Now, if we were building a template class instead of a template function, there is a way we could use some things called traits to ensure and get better compiler errors. This will give if you don't have a pushback, you'll get a compiler error as well. But there's ways that you can use traits to ensure that more solidly, that you have the right functions and so forth in it. We're not going to get into that right now. We'll talk about traits possibly in a later video. Right now, we're just going to use the duck typing method, which says that this collection type must have a pushback function. So let's see how this works. By going over here, we can create a new main function. We're going to include our collect function HPP, and we'll create int main. I'll be a little nicer this time and do a proper return 0, and I'm going to be more specific and put void here. This really should have void too, if we want to be very precise, and we should do a return 0 down here. So we'll put them in. You can uncomment this code, and I'll put some instructions up here. If you uncomment this main function, comment this one out, comment this out, and uncomment this. These two concepts cannot really reside together. They would build up functions that would collide with each other. So you'd get compiler error. So let's go over to our main function here and see what we have to do to use the map result. Let's first of all grab our data. So we're going to have the same int list, int standard list. Oh, we have to include, in this case, we have to include list. There we go. So we're going to start by using a list and see how our function behaves with it. So we're going to go standard list int result equals map let me double check here. We're going to have our int map int. I was looking at the wrong part. I was looking at the part that uses the tuple. Okay, int list, and then our function int item. We'll do something a little different this time. Let's go return item plus 7. So we'll just add 7 to every item. So far so good. We'll go for int int item in int result, and we'll go standard cout item standard endl. And we'll run this. Hopefully we won't get any errors. We did get an error. What I do wrong? Pushback, no overload method takes 2 arguments. Func of item. So we're doing the same thing as we were doing before. We're calling the function here on this item and pushing it into the list and returning it. So let's run it. And there's our list of 8, 9, 10, 11, 12. We added 7 to everything. Now let's just step through here and change this. Let's make this a vector. Let's go up here. Go pound include vector. Let's make this a vector. Make this a vector. And eight, 9, 10, 11, 12. So now this function worked with both list and vector, because this map function. Now, something else that I believe that this did was allow, so that's the simple map. That's zip. I guess I didn't do one. So we could come in here also and go standard vector and run it. And it worked. So what it was able to do, it doesn't have access to our original list. It's not running that one, and it wouldn't work with a vector anyway. With this, it's doing a little type inference. It's realizing what the map function takes, and that this is a vector, and it's allowing a vector to go in there. If we were to take this out and put this in and try to compile this, it should fail, and it did. Even if we put in something like standard list here, it would still fail because it's not recognizing it. This is not calling that list function. So this one here, now it doesn't like it because we're telling it, we're forcing it to say list. If we take that out, it likes it because it can infer the type. Let me check the time on the video here. We're at 16 minutes. So let's go back over here and do the same thing for zip and for filter. And I'm just not going to type them out this time. Hold on, copy. I'm just going to paste these in and explain them because that's a lot of typing. It's the same pattern, right? We've got a template, type name T1, type name T2, and then a template, type name. That's what the template's got to take two type names, and it's collect and allocator. And then we have our collection and our allocator. Our zip function takes that same collection and that same collection. And I called them list here. I should have called them something else. They're not necessarily a list. We could change that to collect one and collect two, and then change this to collect one and this to collect two. And that looks better. Collect one, collect two. And I got the same problem down here. We'll just call it collect because we don't know it's a list. And we'll change this to collect. There we go. And so now we've got zip and we've got filter, and they will work on anything just like before. So let's go over here and let's grab our let's grab all of this, and we'll update it appropriately using, you know what, I wonder, I might have been mistaken here. We'll see. I'm going to comment this out and see if this main function works with these. It doesn't like zip because zip yeah, we need to give zip a standard allocator. Zip int. Why doesn't it like this one? It's the only one it doesn't like. Int standard allocator int. Oh, it's because it needed to be here, and one of these needs to come off. I put it in the wrong spot. Okay, that just needed the standard allocator, and these are all lists right now. We'll change them to vectors. No, it doesn't like something. List on identifier not found. Oh, yeah. Collect one. Missed one. Let's run it. No. What I do now, list 2 identifier not found. Collect 2. What did I make a mistake on? Oh. That was supposed to be, this was supposed to be iter2. Okay. And there they work. They work with list. Well, let's check them and see if they work with vector. That's right. These will work. That's right. These will work with the same. We don't need this. These will work with the same functions. You just can't include both these together. I believe that will cause some errors. It won't be able to decide which one to use if you use a list or something down here. So let's change this to vector. Let's copy it. And I don't care about the names. We'll just change all these to vectors. And we'll change. That's all we need to change, I believe. And it still works. So it works with lists and vectors and anything else that can be supported by this. We'll talk about other collections later. So that's how a template works. Let me make sure you understand this. All this is saying right here, this part, the template part is saying is that what we're going to pass in as a type is a template type and not just an ordinary type, not just some class or an integer or whatever. We are going to give it, the collection type is going to be a template type that takes 2 types. That's the 2 type names in there. And that's all this cares about. And we're going to pass it a T collection. That's the collection type, and the allocator is what that template's going to be. T collect and T allocator. And of course out here we have our T1 and T2, and the same thing up here. This is our actual item type, this is our collection type, and this is our allocator. And we don't have to worry too much about the allocators, except down here when we create these, we need to be sure to pass those in so that it knows that our T collection takes a T and an allocator. And that's what this is, the type and the allocator. The collection type and the allocator. This is the type of the items inside the collection. So I hope that's clear. If it isn't, please leave me comments in the video comment section below, and I will address them as best I can. And if necessary, I will address them in another video, a supplemental video to this. We're going to use these techniques, but we're also going to use some tools potentially that do these things. And I wanted you to understand what they were and how they work before we start using them. It's a really good idea to know how your tools work. Finally, we are going to have very possibly here one more video. I may move on to some other stuff first, but there are some other things that we can do kind of as a functional concept of programming. Besides map, zip, and filter, there are different characters of this type, different functions of this general character that we can do things. For instance, fold and unfold, and possibly some other things. So we will look at that in future videos, but this is enough to get us started on the things we're going to be working on. So we're about 25 minutes in. I think that's it for this video. Thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit the subscribe button, and I will see you in the next video. Thanks for watching.